Hey everybody, welcome back. This is episode 5 of our series for Bitcoin and crypto for beginners. This episode we're going to be covering smart contracts and DApps. I promised myself I wouldn't do this, but whatever. I kind of did, so I kind of didn't. It's all good. In the previous episodes, you've seen my brain melt. You've seen epiphanies. You saw all this. Hopefully this will be even keeled and I'll get it. Episode 4, if you haven't seen it, twice, maybe 3 times, go check it out. Anyways, smart contracts in DApps. Thanks so much for being here. Let's get into it.
Hey everyone, I'm Michael Llewellyn, and this is Smart Contracts and DApps. So I'm here with Ryan again to talk through what is a lot of the things that make up blockchain and Bitcoin for beginners, and we've gone through a lot of monetary history. We've learned about Bitcoin. We've learned also quite a bit on how a blockchain works, more specifically looking at Bitcoin as the prime example, but now we're going to try to move really beyond Bitcoin, even though that's still a very, very big part of the crypto industry, and learn more about like other use cases and applications for blockchains, most especially smart contracts and decentralized apps.
Because like if I understand correctly, like all blockchain technology, Bitcoin is not all blockchain technology, but all all blockchain technology came from Bitcoin.
Yes,
Is that
in a
fair?
sense, I would say that's fair to say, in the sense of like a traditional blockchain structure, like the ones that we've been talking about, is handed down from Bitcoin. And so when we talk about blockchain more generically, we're typically talking about someone taking that original template for Bitcoin and modifying it to do other use cases,
Right.
Which are sometimes altcoins, sometimes they're different public blockchains, sometimes they're like a kind of private chain. But right now we're going to talk more about just smart contracts more broadly and how that works with Ethereum specifically.
Okay. So smart contracts DApps, that's Ethereum only.
Not only, but I would say Ethereum was predominantly. Ethereum was in the same way that Bitcoin was the first to really tackle decentralized money with like the first real use case of blockchain. Ethereum adapted that to really target smart contracts specifically as one of the first like blockchain protocols to really focus on that and to like become successful with it as it has been today.
Cool.
All right. So with that, we'll get a little bit into like these new use cases, like we said, beyond just payments and assets. We'll talk about like how you can basically automate trust. Because when we say smart contracts, it's kind of a misnomer. A lot of people has different interpretations of it. But what I hear when I hear smart contract, I think of like a legal contract, and I think of automating some trusted function. Because normally with contracts, there's a level of trust that you're saying, like, I'm going to trust you to do this, and if you don't do this, like, we have a clear disagreement and breach of trust.
Now, is that what you think about it, or is that what it is?
So I would say that the proper definition is it's just anything, and this is actually created by Nick Szabo, who you remember was actually involved in also the creation of Bitcoin, or like very early versions of Bitcoin. He theorized that smart contracts was just anything that automated something that like a bank teller or a cashier would do. So for example, a vending machine is in a sense a smart contract because it's saying, give me money, I'll give you a product, and it's doing that without any other human interaction, and you can kind of trust the vending machine is going to do what when you give it the money, you trust it's going to give you the thing, at least most of the time.
So is it just like something that's repeatable that needs to be verified and secure?
Yeah. In the sense that, yeah, you want your payment option involved in a lot of these particular.
I promise
smart
there's not a script. I'm just this brilliant.
There you go.
No,
but yeah, no, I mean, and I would say when we talk about. Contracts and blockchain, we're talking about taking that definition and applying it specifically to decentralized systems that can provide some trusted mechanism and do some specific market exchange without any third party having to validate it, or a human having to validate it, especially.
And that's the core of all of this, is keeping it to where there's not a centralized thing, right?
Exactly.
Okay.
So we'll cover kind of contracts and computation. We'll break it down. We'll talk about Ethereum and how those Solidity contracts actually work, which is the language in which you actually write smart contracts for Ethereum. And then we'll talk about some use cases and some of the adoption challenges that we're seeing today. So first, let's dig into why contracts are important, and we'll actually start with a quick refresher. So
I'll admit, like I was telling the guy, we had a meeting earlier, and like I wanted to wrap up soon so I could re-watch the blockchain episode, because that was, if you've watched it, well, you should watch it.
It was a long one, yeah.
But it was a long one, but it was just like my brain was melted. But I'm like, did I get the information? And our meeting went over and I didn't get a chance to watch it. So if I'm an idiot, you're welcome.
That's okay. We brought this here for everyone. So basically,
There
we're
we
just
go.
going over the 3 core features so that we kind of have these in the back of our mind when you start thinking about use cases for smart contracts and whether you want to run it on a blockchain. Do you need these 3 features? So the first one being, like, you want transactions that can't be tampered with, that are immutable, that you have a public record of, and that are essentially censorship resistant. That's like one core tenet. You want it to be verifiable, so we want to be able to verify transaction rules were followed, which can include now not just payments, but also the smart contracts, which are essentially just codified rules that are written in code and put on a blockchain. So do we want to verify that some rules in a smart contract are being followed? Then a blockchain becomes a really viable use case. And then, of course, do we want it to be decentralized with no single point of failure and no particular like individual you have to rely on, at least for certain parts of how it executes?
And do you see this as like equal parts of a triangle, or is there something that's more important than the other?
It's a little bit of a triangle. If we're not talking about the scalability trilemma, but they're kind of analogous to that in the sense that like all 3 of these things I think are core feature sets of a blockchain, and it's very hard to say that your use case makes sense if you're not targeting all 3 of them on a blockchain. Because blockchains are kind of expensive, they're kind of new tech, they do a lot of great things, but they're also like a lot tougher to work with because they're so new. So in some cases, you might be better off using a different system than a blockchain. So I would say always coming to these 3 points and saying, is this something that I need for my use case? And if the answer is yes, then great. Otherwise, you might need to rethink whether a blockchain is necessary, because some people like throwing blockchain in for the heck of it.
And I know we're not doing an episode on this, but like the immutable and the verifiable to me is huge moving forward. And just simply because if I look at my phone, in the time we've started this episode, I've probably got a text from a bank that wants to send me money. Where should we wire the account or whatever? And you're like, this is obviously a scam.
Yeah.
So anyway.
Yeah, and that's actually a big part of potential use cases, which is figuring out better identity solutions. But that's a whole other topic. So let's get into contracts and computation. So as usual, I like to dumb it down and just start with a very simple definition of like what is a contract before we even talk about the blockchain part, which is the simple definition is contracts are agreements that govern the rights and duties of 2 or more parties, and they're often legally binding. So this is your sign on the dotted line sort of contract, the same thing you do for employment, for your lease, for your pension, whatever you essentially rely on some legal obligation for. Typically there's a contract backing it in one sense or another. And so they normally work pretty well, and it's used to govern any exchange of goods or services, most especially. And you also have instructions for how parties should behave and have remedies for a breach of contract. So what happens if they don't pay me? Well, I can go to court and I can get my claim, or I automatically bill you at the end of the month with a late fee. All these different kind of scenarios are played out in terms of like, well, you don't pay me back or you don't provide the service. What happens? Usually a contract will kind of show how those scenarios play out to a certain degree.
And real quick, and this is way out of order, but this I don't care. When you talk about smart contracts, is a smart contract kind of like a web chart of if it does this, if that, if then, that type things?
We'll actually use that exact way of thinking about it to break down our first smart contract.
Well, I'm sorry for jumping ahead.
But no, yeah, that's a good way to define it. It's like, yeah, if this, then that is kind of how like legal contracts work, but it's not specific. It's written in English language and interpreted by lawyers, whereas, and it has to be debated in court, whereas a smart contract will automatically do what's expected, assuming there's not a bug.
Got it.
So, going through an example.
Oh, back to Alice.
Yeah, Alice and Bob, our favorite friends in the crypto. Alice wants to deliver a good to Bob, and then Bob owes Alice for a payment of $10, and there's a contract that binds this particular agreement. If for some reason you really cared about this $10, you would have a legal contract for this. And so with traditional legal contracts, enforcement doesn't happen automatically. You actually need to go to the court system and ask them to enforce something if someone does not play by the rules of that contract. So the contract can tell Bob, or essentially assert that Bob owes Alice the money, but there's nothing that there's nothing that contract or Alice can do to compel Bob to do it without getting a court system involved, i.e. a third party, to kind of render a verdict, essentially. And in reality, that means you lawyer up. And that, even though I would say this is like actually one of the best things about like the American court system and the reasons that this is a great place to do business in a lot of cases, is we have a legal system that we can rely on to be trustworthy. Some third-party countries or authoritarian countries are far more heavy-handed. The court systems are far less trustworthy, and so people are more comfortable doing business in a place like the U.S. because they feel the court system can back them up in business disputes. But at there's limitations to that. It's still not a perfect system. And for the average person, let's say in a case of $10 or even $100 or $1,000, the actual time and cost for resolving something legally in the court, or even through a lawsuit or anything like that, is very expensive.
Because in this situation, even if it is just $10, say Alice has $1 billion and Bob doesn't have any money because he gave his $10 to Alice, Alice could, maybe her runway for paying a lawyer is much longer than Bob's runway.
Yep. Yeah, so different parties, there's a lot of positioning on how parties could arrange contracts in their favor, how they could like pick jurisdictions in their favor, and jurisdictions also have a limitation. So you do business, if Alice is in one country, Bob's in another, the litigation costs go through the roof because just figuring out where you even have the court case would be a big decision point. So overall, like it's estimated that global commercial contract claims resolved by litigation costs almost $870 billion a year. So it is definitely a massive sinkhole for business, and it limits really the ability for certain people to do business in a way that they feel safe, because they can't, in small claims and small instances, especially for small businesses, they really can't rely on the legal system the same way a large corporation can, because actually engaging in that system is just so expensive. You're not going to go to court to sue someone over like $1,000 check, but at least most likely, so basically, you're either not going to engage in that business at all, potentially, or you just have to engage with it with like a certain level of risk that you otherwise wouldn't want.
Because there's is it worth it?
Yeah.
So just to go back to this 870 billion, now is that like lawyer fees, or is that 870 billion that was like within the framework of the contracts themselves? It says litigation costs.
Litigation costs. So that is essentially lawyer fees. Yeah.
So
although
in a year,
yeah,
almost $1 trillion went to lawyers just for contracts.
Yep. Just for commercial contracts on a global scale. Yep. They charge pretty big by the hour, even though we've got some great lawyers working here at the TBC.
But I mean, that's why lawyers get a bad rap, because they make $870 billion off one track of law.
And it's hard work, like figuring out how to navigate different legal systems. I mean, it's being well read on that. Yeah, I mean, reconciling the disputes, and even then, like, you can't guarantee your client's going to win, because you're kind of at the whims of a judge or a jury or specific nuances of law.
But to your point, the reason people trust, at least the reason the global economy trusts the American judicial system, is because, say you go to some random country in South America or within Africa or whatever, there's no guarantee that you're going to even remotely get an opportunity to have a fair trial.
Yeah.
Whereas in America, there may be corruption, but it's not as rampant it's not as stereotypical as some of these other places.
Yeah, in other countries like the ones you're describing, like having to pay people off is effectively the cost of business. So litigation fees are basically replaced by bribes, because that's the way that you get things going. So there is no sense of fairness. There's just who has the deepest pockets.
Well, anecdotal story, like I used to work in Doha, Qatar, and I worked in chemical and materials for like painting, for like construction. And in order to get product to the country, I had to buy a Rolex for the customs guy. Mm-hmm. That's how we got approved. I don't know if that was legal or not, but I'm not a lawyer, and I'm not in Doha, Qatar anymore. And we were shipping from like Dubai to Doha. Anyway, my point being is, you had to find somebody to pay off.
Yep. So ultimately, how do we build a system that gives us kind of the same protections?
Allegedly. Sorry.
Okay, there we go.
Yeah, hypothetically.
Yeah, how would we build a system like this in a way that we have these kind of like almost court protections or legal protections in our commercial contracts, but we don't have to rely on a system that is expensive and restricted by jurisdiction, that is global, that is accessible, that is kind of very much borderless like the internet. Mm-hmm. And that's where in digital commerce we can find that with technology, and most specifically blockchain. So by making contracts smart, this goes back to what I said about Nick Szabo, where he says, smart contracts are a computerized transaction protocol that executes the terms of a contract. So that's what he means by smart contract. It's important to note, smart contract does not mean it's smart in the sense of like AI. It can't, at least most smart contracts today on blockchains can't actually like make human-like decisions, but they can definitely be given a set of instructions and then execute them verifiably.
Yes, because when I read computerized transaction, like again, I don't see AI, I see if then that.
Yes.
That's what I see in that sentence.
Yeah, so when you think smart contracts, think list of steps that it executes, and you can trust it executes it the same way every time. So smart contracts, like I said, he pointed, and this was in the 90s is when he was theorizing this. You have point of sale terminals, you have credit cards, you have these like electronic data interchanges, which are basically just ways that corporations can share data directly. And so these are all kind of methods of smart contracts where people can fulfill obligations, but a lot of these still rely on someone who's running the device, whoever owns the point of sale system, whoever runs the credit card network. These things typically still depend on some sort of a third party to manage and maintain it. So Szabo saw digital cash protocols backed by cryptography as the next logical step for how smart contracts will evolve and basically resolve these contractual disputes that we have over payments. It can be over other things, but payments are usually at the center of it. Did you do the thing I paid you for, or did you pay me for the thing I did? Those are usually like at the core of most commercial disputes. So looking at an example here where Alice and Bob have a smart contract, and we're making it smart, so we put the little hat on it. And the contract says, Bob, you have to pay Alice, and Bob says no. Well, the contract in this case, if it has access to the payment system, doesn't need Bob's consent. As long as it can verify that Alice met the obligations, it can compel Bob to make the payment through several different mechanisms. But within a smart contract on a blockchain, it's typically like it has control of the tokens. It was given access when the contract was created, kind of held it in escrow, and then made the transfer once it verified Alice did her end of it, and Bob can't take it back unless he can somehow prove that Alice didn't do her job. So that's where things have now changed. Instead of having to go to a court system to compel that payment, the smart contract just does it automatically.
And then who would he prove that to, though?
That comes down to details.
Is that a lawyer up type time?
That's a how do you design the smart contract to deal with those scenarios type time. So partially developers and maybe also lawyers. It's actually a big open question for how you do messier contract disputes in a smart contract and prove certain things to it. But let's say that it was an on-chain thing, like Alice was giving Bob some crypto token, for example. You could verify that very easily on chain. Verifying things off chain is a bit trickier. That's where we get into oracles and other things like that. But typically, it relies on getting some.
Whoops! I asked the wrong question. You throwing out words like oracle.
Essentially, an off-chain data source, like somewhere outside of the blockchain that tells us what's going on in a way that we can trust, without relying on a third party. And so, projects like Chainlink dive into that deeper. But I would say for now, know that smart contracts can verify anything on chain, and they can be told about things off chain if they need to. So ultimately, smart contracts are another way of processing transactions in the same way we've talked about it with blockchain, but it goes beyond just the validation of payments, which is what Bitcoin has always been focused on. It can actually go into far more detail around what a payment or a transaction itself should be and what are the steps involved. And we want to make sure that contractual conditions are met in all those cases. So computing a contract, so let's say we follow the same if this then that process for taking actions. We basically, in this case, would say if Alice delivered a good to Bob, then Bob pays Alice $10. So we break it down pretty simply like that. And let's say that this is our little smart contract, and we built out these two steps, and all we need to do is verify what occurred. But this smart contract, as code, does need to live somewhere. It doesn't just exist in the ether, or we're not getting to the ether part yet. It is going to have to be hosted somewhere, and typically, with computer programs, there's kind of this client-server model of code sits on a server and then people ping it and get responses. So it'll either sit on some on-premise computer, like running on your local computer or on like your local server, or typically you'll upload it to the cloud and it'll be managed by a big data center like potentially AWS or Microsoft or Google or other third parties as well. But it's hosted somewhere, and someone ultimately, whether it's on-premise or in the cloud, controls that code. They have access to it and they can change it.
And this is not blockchain. This is just
this is like a smart contract that doesn't use a blockchain.
Okay, because as you say though, because when I look at this graphic on premise, it's like in the whole point that it can't be hacked, but that looks like it can be hacked.
Yeah, or at the very least, someone could definitely access it.
Or alter it.
Yep, exactly. And that's ultimately the risk you run. So if someone controls a computation, even if the smart contract itself can verify things on its own, if someone controls it, then you do have a risk in terms of, even though the code will execute the same way every time, if someone can modify it, you do have a less trust involved. This is where decentralization comes in. It could be immutable, it could be verifiable, but if it's not decentralized, you don't actually have a guarantee of the first two properties. And that's why, like in this example, if Eve is hosting this and she can go in and modify the result if she has like a a backroom deal with Bob to say, I'll resolve this in such a way that you're not owed the payment, and then Alice is left out of the money, and Bob basically got away with whatever like fraud that he was committing. And this is an issue you see not just in the case of like outright fraud and collusion, but sometimes you just have providers of these networks that are resolving disputes in the best way possible for them, not necessarily the users. So like working through PayPal disputes or Coinbase disputes or Facebook, moderation, like all these things that we have to rely on these very large third parties to resolve fairly, and usually they don't do it well because they're better at running servers than they are adjudicating a payment dispute. That's a secondary concern to them, and usually they'll resolve it in whatever way gets things over with as quickly as possible, even if it means one side gets screwed. For example, like the PayPal buyer protection, even though it's good for some people that might be defrauded by a seller, in a lot of cases, the sellers don't have a lot of, they're put usually in a position where if they can't prove that the buyer is lying, they might be like, they might lose out on that.
I've heard so many horror stories of people that they'll do the product, they'll do the service, they'll provide whatever they were intending to provide, and then they'll get hit with like a PayPal payback or whatever, or callback or whatever they call it. Chargeback. And then they're out $2,000, $5,000, $10,000, and they're just like, but there's no, the process to actually fight that out. It doesn't help you that day. It may be 3 months, 6 months, 9 months, a year.
And they're under no obligation to necessarily resolve it in your favor. They're not a court system. They have their little, appeal system that they typically have on these sort of platforms. And if they don't decide to give you leeway or hear your case out, like you're kind of screwed. And there's really no recourse because you essentially put all your trust in that third party to manage the transaction.
And this is, that right there is why I love Amazon. Because because I'm thinking about eBay and how many times have you ordered something from eBay and you spent money and you paid it out, and then you get a notification that something got delivered, and then you look at it, it never got delivered, it never even left the facility, but somehow they were able to trick eBay into thinking that it went there, and then going through the process, the hassle with eBay to get your money back is such a pain. Like there was one time I had to file a police report for a package that was stolen from my front porch for a package that never arrived ever because I have the Ring doorbell thing. It never came. But the reason I bring up Amazon is how easy is it to go to Amazon and be like, hey, this never came. Well, we show it, like, I don't have it. They're like, okay, well, here's your money back, or they just immediately customer service you out.
Yep. And it's a good example of like that's consumer service that like definitely I enjoy, but I'm also very reliant on that through Amazon. So like in a world where Amazon decides to say, I think we're gonna like rank up our profits a bit, we're gonna stop our return policy, like that's gonna hit people hard. But if they're dependent on Amazon, like they might not have a lot of recourse for that. Like if they're so used to it and ingrained.
Yeah, and you know what? Honestly, if they had stricter return policies, I probably wouldn't buy as much as I bought.
Yep.
Because I don't need to spend. I don't need to describe how much I spend, but it's over an order a day.
Yeah.
For the last 3 months was over an order a day, which is not very good as a business person. But if I knew I did not have the ability to return it, if I didn't need it or want it or it didn't work, I might hesitate on clicking buy.
Yep, but that's ultimately in the end, like so much is up to Amazon. And let's say we've had, certainly some political issues lately where certain people have said things that Amazon doesn't like for whatever reason, good or bad.
Right.
Amazon has the power and the legal authority in terms of like they're fully within their rights to do this, to pull people out of their marketplace, to pull people out of their cloud services, and to say, we're not going to do business with you anymore. And if them and then the other 5 leading competitors do that to you, you're out of luck. You're very much dependent on a lot of these third parties, not just for payments, which is what we've been traditionally talking about, but also everything: cloud services, server systems, security, authentication. A lot of things that are like crucial to running a business online is dependent on a very small group of companies, and that's ultimately where. And they're not. There's actually a great quote by Yanis Varoufakis, who used to be the Greek finance minister during the debt crisis they had back in 2012. He described the world that we're moving into with tech as techno-feudalism, in the sense that you don't have the same sort of capitalist structure on the internet if Facebook in the Facebook marketplace has all the control. They're the lord, everyone else is a serf, and they're just given permission to do whatever business they want and give a slice to Facebook. And at any time, Facebook can kick them out and say, you're not going to do business here, and they have completely like legal authority to do so. And that, like, if you put that into the real world and you had like a big marketplace that someone could go around and just ban people left and right with no recourse, that would sound like a autocracy. And I mean, I say this like this is a very new form, so I don't want to be too alarmist, but I think people are slowly realizing, because normally like Facebook and Amazon try to behave because they don't want to abuse the power to the point where people don't use them anymore. But over time, you eventually do see these like circumstances where they're willing to exercise that power that people didn't realize they had.
And we don't need to tangent too much, but it's coming more and more frequent. Like if I go and eat a cookie and nobody slaps my hand, I'm gonna eat a cookie again.
Yeah.
I'm gonna eat a cookie again. Next thing you know, you're the size that I am. But the point I'm trying to make is like, if there's nobody stopping you, at some point you're just gonna keep doing it. So like and I think, we don't need to turn this to a political show, but I think there are some instances in the past couple of years where, say, when certain Republican types were getting censored from like big tech, that was okay. But now when that censorship comes towards like the Democratic side, they're like, I think people are starting to wake up, like, oh,
Yeah.
wait a minute.
Well, both sides got to get whacked to realize it's not a one.
Right.
Yeah, it's not just them.
Yeah.
It's anyone potentially.
Well, I mean, even Sarah Silverman, a comedian, she was being canceled the other day for just making a statement about how, you should probably read up on the subject matter before because she's basically telling somebody on The View, you're an authority figure. You need to read up before disseminating false information, and they immediately said she was racist. So even Sarah Silverman, who's a bleeding heart liberal, super left, she's like, wait a minute.
Yeah.
So even now, and if somebody like her can wake up, hopefully. And again, it's not about waking up, but you know what I'm trying to say.
I think realizing the risk you run by using and depending on a lot of these big platforms.
Yes,
that's ultimately what comes back to this.
How
is
do we get
how
on
do you?
this? Yeah, how do
Oh
we?
yeah. But essentially, what are all the dark, what are all the downsides of the internet we have today?
When it's centralized.
When it's centralized.
Got it.
The internet, and I think you could say a broader discussion around like other things, but like most especially like just internet services that we rely on that do things that are kind of similar to a legal system in the sense that they do marketplace transactions and things like that. Should we really be trusting them to this degree? And if we don't want to trust them, what's the alternative? And that's where a blockchain-based smart contract system comes in.
Thank you for bringing it back.
Yeah. So ultimately, blockchain technology is one solution to fully decentralize trust, or I'll say to decentralize it to a level where we feel like we're on a level playing field when we're engaging in commerce online.
Because that's the whole point of it is like if you don't want to trust a figurehead, or if you can't trust the figurehead, then if you trust no one, then in a sense you can trust everyone.
Yep.
Did I just make that up? Is that profound? I don't know.
Possibly.
Can I meme that? Somebody meme that.
But it's important, it's important to say, like, the whole point is here that everyone feels it's accessible and everyone understands it and it's transparent, so they feel much more comfortable engaging in it and trusting it in the end. So Bitcoin, in a sense, still provides some of the first decentralized smart contracts because it does do payments. In addition to payments, it can do other things. It can do a multi-sig arrangement where it's like 2 out of 3 of these keys have to sign a transaction to send the Bitcoin. So you could there's a company called Unchained Capital using that to do loans where they actually use the borrower and the lender have one of the keys and then a third party has another key, and they can do dispute resolution if the lender and the borrower don't agree about a transfer. The third party can come in and help resolve that dispute for them.
And they're part of the Texas Blockchain Council.
They are. They're
Austin.
Yep, they're one of our biggest supporters. Yeah, thank you.
Yeah.
And but with Bitcoin, you have a lot of these interesting features you can play with, but it wasn't built for smart contracts in the same way that we've kind of been describing it for normal use cases. It was built mainly just to do payments, and specifically payments in Bitcoin with only a few extra things you could throw on top. So Bitcoin smart contracts were limited as it wasn't built for that. And even today, even though people are trying to do more Bitcoin smart contract things, it's still kind of being like, I would say, jury-rigged in there, in the sense that it's just not traditionally built for that, even though people are trying to build layers on top to provide it. Like Lightning and Impervious AI is another company that's trying to do some interesting things with Bitcoin smart contracts. But going back to like the 2012, 2014 era, this is when people were saying, oh, we could do all these cool use cases, but Bitcoin really isn't giving us the tools needed to like make them happen. And so that's where you saw people like Vitalik Buterin, who was a very early Bitcoin supporter. He wrote for the Bitcoin magazine for a while. He wanted to add a general purpose scripting language to Bitcoin. And he got a lot of pushback because a lot of people said, hey, we don't want to, add all these complicated things into Bitcoin, and it potentially makes it more complex.
And what was the year of the Bitcoin Cash split?
Oh, about 2017. So this is
okay. So
far
this is well before that. Okay.
Yeah, and this is where in the industry the groups were still fairly small. Bitcoin was just now coming out in the public consciousness. Even then, it was very poorly understood. And so this is like really deep in, where like people are way ahead of us. Like even talking about NFTs back in 2012, they just didn't know how or what they would look like, but they knew they were possible. There was this idea about them. And Vitalik's like, we should execute this with programming language. Bitcoin people said, let's keep ourselves focused on Bitcoin and payments, which, to its credit, I would say it keeps Bitcoin simple and it keeps it focused on its core mission, which is to be good money. But for Vitalik, what he wanted to say is, hey, since we're not going to do this for Bitcoin, we don't seem to be getting a lot of traction there. He proposed doing his own thing, which was the Ethereum white paper he put out in 2013. And he said, I want to create a new blockchain protocol that was specifically built for custom smart contracts. So anyone could write up a smart contract real quick, anyone that was like a basic developer, deploy it on this blockchain network, and it would be immediately available for anyone.
Now, is that one statement why so many people are, like when it comes Bitcoin or Ethereum, it's like, well, this is not financial advice or anything, I choose Ethereum because there's applicable aspects to the blockchain versus the Bitcoin is just a currency.
Yeah.
Is that a fair?
It's a tough one to make. I would say it depends on what you want out of it. I think Bitcoin's money statement has a lot of value on its own, especially the store of value narrative.
Right.
I think like Nick Batia's Later Money like lays this out the best. But and even though there are ways to do smart contracts on Bitcoin, it's just not focused on that, and it's not very like intuitive. So it is really just focused on being good money, and Ethereum is in a sense focused on being a smart contract platform, and it takes.
The point I was trying to make though is like the people that are excited about it are because it has so many more applications.
Yes, that's true.
What I was trying to
they see it more as like an app store than a specific app.
Right.
In the sense that they see like this could be far broader than just any specific use case.
Bitcoin,
we can't even think of the use cases, and people could come up with them later.
Whereas Bitcoin, they would say it's the only app.
Yeah, potentially.
Or the only app store.
That is the way some people see it. But I think there's also a lot of people, including Satoshi Nakamoto, who see like additional like protocols using the same blockchain format as a good thing. I mean, he hasn't said anything publicly about Ethereum because he went offline before it was really a public discussion. But he did like call out other protocols like Namecoin that were trying to do something similar. Namecoin was actually trying to make a decentralized domain system for the internet very early on, and he said positive things about it in the sense that he was like, Bitcoin's going to do Bitcoin stuff, and Namecoin's doing a very different thing. And Ethereum's doing a different thing than Bitcoin. It also has a currency. It also has some of the same properties of Bitcoin, but it's really trying to do a different mission, which is not just good money. It's trying to be a smart contract platform.
Now, if I want to do a smart contract between you and I want it to be housed on the Ethereum network or whatever it's blockchain, now is that just something that I do it and then I upload it, or is there like a centralized platform that a way about doing that?
Yes. So good question.
Or is that like not appropriate for right now?
I'll bring that up in a second, but okay. I guess I'll say that what the white paper describes is taking these same like concepts of a smart contract, and they actually describe decentralized applications, which is what some people call DApps, running with smart contracts that use the Ethereum virtual machine, which is basically, you might hear Java virtual machine or other things like that. It's basically just, it simulates a computer inside of the node. And that's a computer that can run programs that people feed it, which are these smart contracts. So when you hear EVM, just think it's a distributed computer, essentially. And they some people sort of describe Ethereum as a world computer, in a sense. And that computation is decentralized, and it's not controlled by any specific third party. So you have that same smart contract running on Ethereum. Anyone can call it, anyone can access it. It's open to everyone. So with that, let's dig a little bit more like what Ethereum smart contracts actually look like, and what are some features that it has. So Ethereum, first of all, has state storage. And by state storage, I mean it can store generic data. So Bitcoin has transactions, and you can store Bitcoin balances, or rather, you just store transactions of Bitcoin. And if I want to figure out my balance, I just add up the amount of Bitcoin that I've received and subtract the amount of Bitcoin I've sent. And that's your like UTXO, your unspent transaction output. And so all Bitcoin has to do is just store transactions, and that's fine. It doesn't do anything else. But if I wanted to actually like get the data of the blockchain with Bitcoin, it doesn't really work well for that. Like there's no place where I can point to a specific part of the blockchain and say, this is where my balance or my data is. It could be scattered throughout all these transactions. So what Ethereum did, and this is kind of more of a, I guess a developer nice to have, is it created a state system where you actually can store state directly in a separate tree, a separate Merkle tree, in fact. And it basically all says is like your balance, for example, your Ethereum balance can actually live in the blockchain as a specific number as opposed to having to calculate it by hand.
Real quick.
Yes.
Only because I'm an advocate for the audience. It has nothing. I know.
I
know what a Merkle tree is.
I knew this was coming.
I know what a Merkle tree is. But for the audience's sake, please remind us what that is.
So a Merkle tree is a data structure that lets you verify a large set of data. So I put in a whole bunch of transactions or a whole bunch of like different state like pieces of data, and then I can verify it very quickly. Right. And usually in the case of a blockchain, I'm verifying it's part of the blockchain and it's immutable and verifiable and that sort of thing.
And then you can also, if there is a flaw or an error or a corrupt or whatever, you can identify it very quickly.
Yes. Yep. In the case of Ethereum, it wants to track both state and transactions, so it's doing more than Bitcoin does. And that's specifically because if I'm a developer and I want to be able to, calculate how many NFTs I have in my wallet, I want to be able to just go and look at a specific point on the blockchain to say this is how many NFTs I have or which NFTs I have, in like a really simple data structure. But with Bitcoin, it would be, or Bitcoin or other like UTXO chains, at least with the way they are currently, you'd have to like track it down.
You said that real quick. UTXO what now?
Oh, UTXO chain. So Bitcoin is based on UTXO. When I say UTXO model, it just means it only uses transactions to calculate balances.
Okay.
So you have to like add it all up every time. So like when you look at your Bitcoin wallet and it says you have like 5 Bitcoin, I hope. It's not. There's no like
5 Bitcoin, please. More like 500.
There's no place.
Where's my top hat?
There's no place that it actually shares that as a 500 number. It is just doing all that math for you and then showing you the final balance. Mm-hmm. So which is fine for that. It's actually more efficient in some ways, but it's just really hard for developers to keep track of things if you have like multiple balances and multiple coins and multiple smart contracts, because that data gets scattered and it's really hard for like, for example, a smart contract to add 2 balances together and subtract it and do other operations. It's just much better if we have a good state model. And that's a design choice that Ethereum made early on. And then the other thing it does is it has faster block times, which basically means 15 seconds instead of 10 minutes, primarily because it's a better user experience comparatively.
And this is a big callback to the previous episodes about the Bitcoin Cash, was they wanted a faster...
I don't know if they had a faster block time, but they wanted a bigger block.
Okay.
They wanted to be able to put more transactions into a block, and so they would increase throughput. In the case of Ethereum, they still have a fairly limited throughput, like it's still probably like around 10 transactions or less per second, but the block times are faster, so you can figure out your transaction was confirmed in 15 seconds as opposed to 10 minutes.
Right, that's much more efficient.
Yeah, and they did have to account for that global latency we talked about, because the whole reason Bitcoin has 10 minutes is so every miner around the globe can catch up and make sure there's no like forking, like people on different versions because they didn't hear about a new version.
That blows my mind, and I just figured, I just clicked. The reason it's 10 minutes is so the global network can all be on the same page.
Yep. Essentially.
But to me, that's insane, because when you think about it, like, yes, it's 2021, almost 2022, and only 100 years ago, how long did it take to get a hello from one part of the globe to another? And now you're able to like verify the entire Bitcoin, whatever, in 10 minutes.
Yep, and in the case of Ethereum,
it literally just.
In the case of Ethereum, it's now 15 seconds.
That's stupid. In 15 seconds, it could do the entire globe.
Of its own state, yes.
That's insane.
And it does have to figure out a way to resolve the issue of what happens if there are some nodes or miners that are on a different version because they didn't catch up in the last 15 seconds. And it solves that with something called uncles, where it will actually, and uncles are essentially like a block that someone mined late because they didn't hear about the new block. And the risk you run with allowing uncles to propagate is like people create their own forks of the chain. And when you go to a miner and say, no, you didn't, like someone solved that block first, you don't get that reward. They're like, well, fuck you, I'm just gonna keep it. And you'll have forks on chains because miners want to keep rewards that they felt like they found it, even though they didn't find it first because they just didn't hear about it. So what an uncle system in Ethereum does is it just rewards miners partially if they find a block that ends up being out of sync. So they just give them like a quarter of the reward just to say, hey, you mined it late, but we'll give you a consolation prize so that you play nice with the network, and that's worked out pretty well. So ultimately, it's got a lot more usability, and there's also like work with proof of stake to like reduce that block time further. And some blockchains have like sub 5 seconds or less. So you have other interesting systems as well. And then finally, it's Turing-complete, which is a fun computer science definition. But I would say the easiest way to think about it is a Turing-complete system basically means it's capable of computing anything that could be written in a modern programming language. So for example, your calculator can do a lot of cool things in math, but it's not Turing-complete because if I like came up with a program like Pac-Man and fed it to your calculator, it wouldn't know what to do with it. So it is kind of a computer, but it's not a Turing-complete computer. Versus your laptop that's running an operating system because it has its own like CPU and things like that, can theoretically run anything that I program for that specific hardware. So a Turing-complete computer can just basically process anything. And so like most modern languages like Java, Python, JavaScript, and Solidity, which is the programming language for Ethereum, are Turing-complete in the sense that you can theoretically write anything for it. And that's what really opens the door for Ethereum to do some really cool things, because now you've got a Turing-complete environment in which a programmer can build anything that they want to their heart's desires within certain constraints, which in the case of a blockchain is typically time and computational cost. But even within those bounds, you get a lot more flexibility than you get with something like even Bitcoin. Bitcoin is technically not Turing-complete because it only has instructions to do specific things in Bitcoin. You couldn't do anything arbitrary. You have to do it like within a Bitcoin payment script or specific scripts and opcodes it allows.
So I feel like I haven't been necessarily asking enough questions. So on this slide specifically, what should I be asking? Or is everything just so above my head that I'm like, yeah, I get it?
I mean, really, what I'm presenting here is like what is different about Ethereum versus Bitcoin. Because remember that Bitcoin, or Ethereum, is based in a large part on Bitcoin. It has the same blockchain structure. It has similar cryptography. It follows a lot of these same models, but this is what's getting added. This is what, you have your typical Bitcoin system, except it's got state storage, it's faster block time, it's Turing-complete. These are the main differentiators. Turing-complete with the Ethereum virtual machine being the biggest, I would say.
I have a question.
Yes.
I came up with one because that's how I prove my worth, is having questions. What is the state in state storage? Like I know what storage is, but I don't know what the state is.
So state is kind of a computer science term, but basically it just means it's something stored in memory typically, and it's something, and it's used more abstractly as like a way to think about it theoretically. But basically what I'm saying is like your state right now is you have a black shirt on. Like that's your state. Transactions, so state is like something that's frozen in time as this was what we currently believe. This is what currently exists. A transaction is something that changes it. So for example, if you changed your shirt from black to red, you could call that a transaction from black to red.
Right.
And a state would be your shirt is now red.
Right.
So you actually see this lovely diagram where it has state and then state with like an apostrophe and a transaction in the middle. So that state exists. A transaction happens that changes the state, and then you have a new version of that state.
Got it.
And so in the case, going back to Bitcoin, Bitcoin doesn't do state in the sense that it trusts someone to look at all the transactions and figure out state on their own. Whereas in Ethereum, we want to do that for developers. So basically, if I wanted to know what shirt you were wearing, I would have to look at all the transactions up to the latest one, or at least the latest one, to know what that shirt is, versus looking in one place that says, no matter what the transactions that have been, we'll always update the state based on what the transactions were, so you can always look at this one place and see color of shirt is red, versus you looking at the history of shirts.
I'm glad I asked that, because state storage, I got it, but then I was like, I don't got it.
Yeah.
But now I got it.
Yeah, in like the case of banks, for example, like at the end of the day, their state might be your balance is $100, and then they add up all the ATM and pending transactions, and then they reflect a new state, which is your new balance.
Right.
So most systems use state storage in one way or another, and transactions are just the changes in between the state.
So, I mean, the easiest way to remember that is what's the current state of things.
Yes, exactly.
Got it.
All right, sweet. So
God, I love being smart.
now let's look at how this plays out in the account model. Because the other thing that's different about Ethereum is it has two different kinds of accounts as opposed to Bitcoin, which has one. And so in the case of Bitcoin, it is very similar to what is called an externally owned account for users. So this means we have our typical users, Alice and Bob. They both have a public key, they both have a balance, and they have a private key from which they can send transactions. So this is just like Bitcoin, like they have public key, private key, that controls some amount of money. That's an externally owned account in Ethereum. However, what you also have in this world now is you also have contract accounts, which is for smart contract code. Because not only is smart contract code able to be executed on chain, but it does so from sort of its own account. So when I create a smart contract, I don't just put this code on chain, I also create a public key for it, or it's generated for me. So I can actually point to this account in the same way I can point to a user and say, this can handle money and do things. And in the case of smart contracts, it's usually given, it has the ability to hold money, including Ethereum, which is called Ether, as well as other tokens that people build as smart contracts. We'll talk about those later. But it has some associated code that actually explains what it's supposed to do, specifically usually with funds, and then also some state that basically reflects what's currently going on and what does it need to resolve, like actions that are taken. And it's triggered by transactions. So a smart contract sits on the blockchain and it waits for someone to poke it. So if Alice wants to do something with a smart contract, she can send a transaction signed by her private key to the smart contract, and the smart contract will then take some steps based on the code it has been written in.
And now, my GPU miners that are heating up my house at the moment, is it basically just saying, like, when it's mining, what it's actually doing is just, like, taking care of Alice and Bob?
In a sense.
With those contracts?
It is, miners are essentially trying to calculate the nonce for the next block, and whatever node that actually assembles it, which might not be your miners, but it might be like the mining pool, for example. It's right. Running a node that does this on your behalf, but that mining node is assembling all these transactions, including the smart contract transactions, processing them, validating them, and then they propose a block, and the rest of the network double checks it. So you're participating in that as a miner by just helping create that block through the mining process, and then your mining pool will assemble the transactions and propose them. So, but yeah, so now not only are we like validating transactions between two different parties or multiple parties in the case of Bitcoin, we're also doing it for smart contracts that are given code that lets them execute things arbitrarily. So, for example, let's say that we have this smart contract we've created for this whole service payment. And Alice signs a transaction to mark delivery complete. And this is where we would just say, we're assuming that there's some way we can trust that when Alice signs this, we assume delivery is complete. This is where an oracle might have to come in to make it more trustworthy. But let's say, she signs that transaction complete, and then she is able to send that transaction to the smart contract, and it runs the code, and then it updates the code has its steps, and it updates the state to show that basically Alice went from not delivered to bang, delivered. So the state of the smart contract has changed. So we now know that the state is that, Bob held up her end of the bargain. Bob still has not paid, and so we know that the smart contract would, the next step would be it would handle sending the payment to Alice.
Paul, you getting all this?
Oh yeah.
Yeah, Kevin?
100%.
All right, cool.
All right.
Audience, are y'all getting this? Leave in the comments below if you're up to speed.
All right.
I don't need to verify if I'm up to speed because I've got it.
There we go.
Merkle trees, psh,
All right.
smart contracts, got it.
Now we're going to have fun. So now we can actually look at code. Since you're so up to date.
Oh, damn it. I just, literally, let's just dig a hole real quick.
Oh, boy.
In real time.
We'll take it step by step.
All
So
right.
smart contracts on Ethereum are written in this programming language called Solidity that was custom built for Ethereum. And it's kind of like, if you've heard of code before, it's kind of similar to like a version of JavaScript and Python and maybe a little C. It has specific properties that I'll take you through step by step. So the first thing we're going to do is we're going to define a service contract in Solidity. And whenever you create a contract, you actually just literally say, I want a contract name this, which is in this case would be delivery service, and then I put 2 brackets, and within those brackets are going to be all the code that makes up that smart contract. If you were familiar with other programming languages, this would be similar to like a class, which is just a way to encapsulate an object of stuff that you want to contain. So it's just a way of mentally thinking about it that in a way a programmer or a human can understand well. And then the code gets turned into binary and the computer runs the rest.
So let's dumb it down real easy like.
All right.
Solidity, it's just a programming language.
Yep.
But who's doing this?
Who's writing the code?
Because it's not like, hey, Paul, I want you to do this thing, so I'm gonna create the smart contract, and it's from me to you, because I'm not a coder, he's not a coder. Like, who's doing that?
So mostly developers. So developers that have learned Solidity and started building it on the Ethereum blockchain.
So do I go, okay, I want to have a contract with Paul and Kevin, I want it to be a smart contract, I need to hire a developer? Are there companies that do this? Is that their sole purpose?
Oh, yeah.
In creating smart contracts for people to do stuff?
Yes, although...
I said I would go dumb it way down.
No, I think that's a good question because it is a good discrepancy to address in the terms of, like, smart contracts on Ethereum don't need to be built by everyday people to be used by everyday people.
Right.
And
I would say because everyday people that may be watching this might be like, okay, I don't know how to program my I don't even have to do a WordPress site. So how am I supposed to do this?
Well, and that's a good point because WordPress works well because, or at least it works fairly well because it's like repeatable. Like it's a framework that anyone can use and extend, and that's what you can do with smart contracts.
Anyone.
But it gets better over time usually. I mean,
Right.
like Squarespace, for example, is a lot easier than WordPress now, and that's like an iteration of website building tools that still uses code, but none of that code has to be used by a user because it's so generic and drag and drop. And that's where smart contracts are going to head.
Well, and that's the thing is, and I'm glad we're bringing up this just because, like even with our website, harperbelmont.com, I don't know why I did that. But like, I had a developer make it on WordPress like a while back, but it's so complicated that I need something that's more easily updated. So I actually hired a VA to like, hey, create this on Wix. That way we can edit in-house much easier than having to go on WordPress. I'm like, is this how I do it?
Yep. And that's the thing. That's where we're going to go with smart contracts, where there's going to be a lot of layers built in smart contracts where the things that people have to interact with are already written, or they're written in such a way that they can use a template and then deploy it. And that's, I think, where we're going to go. So looking at this example, I'll kind of give some examples of how that would work. So first we create these variables, which is just actually where we store the state. So literally think like every variable is just a little place where I store a bit of data that I want to hold, and the type of data it is. So for example, a Boolean is a data type that literally means yes or no.
It's the 1-0.
Yep, it's 1-0. So in the case of this, it's a Boolean that says Alice was either delivered or it was not. And it defaults to false. So it's going to say Alice was initially not delivered, and we would change it to true eventually. And then we have another one which would store an address, which in the case of Ethereum is just a public key. So we store the address of Alice in this case, so we know where the payment would need to be sent. Then we also store the address of the buyer. In this case, that would be Bob. And then we define a constructor. And so a constructor is commonly used in a lot of programming languages, and all it means is run this once when you're creating this thing. In the case of a smart contract, when you initially deploy it to Ethereum, it's going to run the constructor once, going to do some setup stuff, and then it's going to stop and it's going to be done. In this case, we've made our constructor payable, which in a Solidity means it can accept a payment when it's created. So if I wanted to create this contract, I could also send a payment along that same transaction that creates it so that it can hold money. So in this case, I'm going to create a constructor, and I'm going to put a require statement in there that says message.value, and all that means is the transaction value. So the transaction creating the smart contract needs to also have 10 Ether attached to it. So when you create the smart contract, you need to give it 10 Ether, because that's the payment we're going to use. And if it doesn't give me that payment, then the smart contract will just not be created because it hasn't met the conditions that we've laid out for this contract. So
but this is just an example.
It's an example, but this is valid code.
But I was just saying, because like what I'm seeing is like this, just to create this contract costs $30,000.
So that's
$40,000.
Yeah, so this is definitely, the value is an example. So that's not the gas cost, that's just the payment we're going to put in the contract for later.
Okay.
That's like the escrow.
Got it.
So smart contracts on Ethereum can be costly to use, but that's not the expensive part here. And then we are also going to store the information for the buyer. So we're going to assume, in this case, the person creating this delivery service contract is Bob.
Mm-hmm.
And so what message.sender means is whoever sent the message, i.e. whoever created the smart contract, we're going to save their address. So that's all the constructor is doing. It's saying, whoever's a buyer, create the delivery service contract, give us 10 Ether, and we'll save your information so we know who you are later. And then the next thing we can do is we can create a function, and a function just means a specific step that we want to perform within the smart contract. In this case, we want to mark it a payment that was done as delivered. So we'll basically say we'll accept a status of true or false. We'll require that the message.sender is Alice. So we basically say whoever is calling this function has got to be Alice. Otherwise, the transaction fails. So only Alice can say it's been delivered. And again, we're just assuming we trust Alice to be honest. And then we would mark Alice delivered as true, which is actually a little bit of a typo, because I should really be using status instead of marking it true arbitrarily, but it works either way. It's definitely not the cleanest code. But after that function, we would have another function which does the send payment. So we provide a function that lets Bob finalize the payment after delivery. So we put in another require statement, and notice we have these like double ampersand here, which just means these conditions both have to be valid for this to move forward. Require statement, all that means is like this condition is everything within the parentheses is either true or we revert the transaction and it never happened. Cool. So we require that Alice was delivered, so this needs to be true, and then we require the message.sender is the buyer, i.e. Bob. If those conditions are true, then we will transfer 10 Ether to Alice. So and this would go through all the steps we've outlined for a delivery service contract. It's very simple, it's very dumbed down, but this is where a smart contract can essentially hold these funds. And this is very simple. Like we could put other additional functions in here. For example, if Alice doesn't pay after 30 days, maybe we send the payment back to Bob, and other conditions that would make this more trustworthy for whoever was using that contract. But this is, so yeah, I guess questions on how all this code works.
I think as far as questions go, it goes back to what we were just discussing about how, like, where is this applicable? Like, I think that's the biggest question of what are the uses? Because as a layman, I never need to know the code. I don't need to know how an engine works to go from point A to point B. I don't need to know that. You know, yes, in theory, I need to know that it's verifiable, it's immutable, and all those mumbo-jumbo blockchain terms, but I don't need to know the functions and the contracts and this stuff, the code.
I gotcha.
But where does it apply? I guess that's the biggest thing. And then how to use it.
Yeah.
Because, again, it goes back to what I was saying before. If I want to do something with Paul or Kevin, how?
All right.
You know, what and how is the biggest questions.
So I'm actually going to breeze through this because even though it's really interesting, I wrote these slides initially for students that did have to had to write smart contracts themselves, so I get a little technical. I'm going to summarize this one up.
Everybody, the entire audience, has to write code.
Nah, but it's neat to figure it out.
Texas Blockchain 1, your code that needs to be done. Anyway.
And a good example of why you don't need to necessarily write it is like there's, for example, templates built with the OpenZeppelin library. And you can actually go to a thing called the Contracts Wizard, and it will, like, if you want to create an ERC20 token or a 721 token, it will like actually generate the code for you, and then you just take that code and deploy it. So you don't actually have to write code technically.
So there's a website. I'm assuming it's a website.
Yeah.
That you go in, and it's almost like a Mad Libs thing, where it's like enter this, enter this, enter this.
Yeah,
enter
like
this.
how many tokens do I want? What do I want it to be called? Do I want it to be mintable? Do I want it to be burnable?
And then it deploys it as well.
You'll deploy it yourself, but you basically can do that step very easily. Like I could teach anyone how to do that with enough time and effort.
Challenge accepted.
Yeah, but I just give that as an example of how I think over time these are going to get easier and easier for people to use without like even the part where you have to see the code, it might not even be necessary at some point. You just put in the parameters and it does it. And there's already tools, I'm sure, that do that.
Right.
So what I'm going to talk about here now, though, is like why you hear about gas fees and why computation is expensive on Ethereum. Because it's being replicated across so many nodes, we have to understand, like, okay, what is the actual cost for running a smart contract?
So before you do that, when you asked me if I had questions and I asked all those questions, you're just like, you don't need to answer those questions?
Wait, what was the first?
You asked me if I had questions. I was like, yeah. Like, how do you use it?
Oh.
Who's to use it? What are the applications? I guess just applicant.
Yeah, sorry. That I thought that one might have been the next slide. So I am.
He was like, "Ha ha! I'm not answering nothing.
There's
I
a full.
just want to make you look like an idiot."
There is a full slide for use cases that I will dive into. That are starting points, and I will actually I'll give you an answer for now, saying it still can be almost anything. And so far, what we're focusing on are like tokens, NFTs,
Right.
and a few other like use cases around that in DeFi.
Okay.
Which is a whole.
So
other
you
topic.
were intentionally trying to make me look like an idiot, more so than I already do.
Totally accidental.
Okay.
So basically, just the reason that you hear about gas fees on Ethereum and there's like a high transaction cost to using smart contracts is you have to like replicate this across the whole network, which does cost more than like a typical server, for example. So we have to incentivize nodes to run these transactions, and the same way, just like in Bitcoin, we want to be able to protect them against spam. So, for example, if I put in a smart contract that just constantly loops over and over again, that'll just clog up the network. So the question is, how do you incentivize people to run these transactions and protect against spam? And that's where gas comes in. And gas essentially assigns a fixed cost to each operation on the Ethereum virtual machine, essentially at each piece of computation. So in the case of Bitcoin, you're only doing a few things, which is mainly just validating a Bitcoin transaction. So you can put a pretty standard fee on that and then compete with other people to say, like, okay, how much are you willing to pay? And the highest fees get included in the block, and people that fall short have to wait a while. In the case of Ethereum, it actually breaks down even further. It breaks down per opcode, which essentially means like each process that a CPU would have to do, or a virtual CPU would have to do, would be like broken down. So as an example, I could take like this math operation of A plus B minus C times D equals E, and I could break it down into its gas components and say like add's going to take 3 gas, subtract 3, multiply is going to be 5, equals going to be 3, so a total gas cost of 14. But this would apply to anything. All the computation in a smart contract would be broken down in that way. And with gas, I have like a constant measurement. Like add is always going to be 3, multiply is always going to be 5. But I can then take this and apply it to a market, and I can basically say that whatever the gas cost is times the gas price, which fluctuates based on the market. Gas price can be 300, 200, depends how much people want to use the network. That's going to determine ultimately the cost of that transaction. In Ethereum, and Wei is just like a really, 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 really tiny amount of Ethereum. It's like the base unit. It's like the atom of Ethereum transactions.
So there are constants in the gas fees but I don't understand
So gas itself is a unit of cost that has a market price.
But is there for different transactions require different types of gas fees?
The gas cost of each transaction could be different depending on what you're calculating and what the market is at the time.
Right, because that's what I say. Because I understand gas fees are up and down or whatever depending on what you're trying.
Yep.
Like, because I know if at least in my anecdotal experience, when I'm in my mining, when say Ethereum is down a little bit and it's not, it's hot and heavy. There's not as much interest in the world at that point in time. Mm-hmm. Gas fees come down to 42.
Yeah.
But then if it's on a tear and it's rising, I've seen gas fees up to 200-300.
Yep. And that could be in Wei or Gwei. It depends on the unit.
It's in the Wei.
Okay.
Or Gwei.
I think it is Gwei. And
yeah.
That's just a larger denomination. There's a lot of Wei denominations.
But what I'm getting to is like, if there's like, what's the do math function? I should ask.
So that's like an example of like I could write that as an
example.
Yeah,
okay.
I could write that as a smart contract function, and if I executed that function, this is how much gas it would roughly cost.
But as far as the gas price, what it goes against, that moves around a lot based on demand or whatnot.
Yeah.
But then there's cost that multiplies against it. That's constant.
Let's break it down just like the best analogy is like they call Ethereum the oil of crypto. You drive from here to your office and back, and that's a commute that is always going to take a certain number of gallons. But the price for that is going to be determined by the market. So like actually filling up your tank, that cost could fluctuate depending on the price per gallon for gas.
Right.
So that commute is always going to be the same in terms of consumption of gas, assuming it's like the same way in the same car. But the cost could change depending on the market.
And then also because in that example you have amount of gas and you have price of gas. In this situation, it's like the type of contract determines the amount.
Yes.
And the price is always.
Yeah, just like a different car or a different commute would change the price.
Yeah.
So both are going to impact. The difference, of course, being the biggest difference being, your car, the price of driving your car is determined between you filling up gas not every 15 seconds in the case of Ethereum, where the price of gas could change between each block, and it often does, depending just entirely based on market demand.
I got this.
All right.
I got it.
So yeah.
Paul, you got it? Yep. Yeah. Oh, I'm going to quiz you later.
So ultimately, like Ethereum fees are kind of like a microtransaction approach where you pay for what you use. So so it's kind of like it's different than the typical SaaS model where you have a subscription or license. You're just paying for what you use in cloud computation and AWS. It would be similar, but you're paying in a distributed way in an open marketplace that kind of bids on the right to process your transactions, or you're bidding on having a miner do it for you, essentially. So they're typically more expensive than normal computation, and that's why I kind of like stressed at the beginning, do you really need to use a smart contract or a blockchain for this? Because smart contracts, especially in Ethereum right now, are very expensive. And granted, there are ways to scale that. We won't get into that too much, but like rollups and side chains and other versions of Ethereum that are faster and cheaper are all coming out to like address this problem. But even in the best case scenario, it's still going to be more hassle or more expensive than a normal program because it's so distributed.
So when you say more expensive or too expensive, put that into context. What does that mean? Are we talking $1,000? Are we talking about $10,000? $1 million? What are we talking about?
Depends on the transaction, but I would say for like an average, like moving Ethereum around can cost as much as $10 or $20 at like high points.
But that's not a smart contract. That's just moving.
A smart contract. So a smart contract, like for example, actually, let's go back to real quick, like to this right here where it does this transfer, that is an Ethereum transfer.
Right.
So you actually here would have both this transfer and the smart contract computation taking up a certain amount of gas. So what I'm saying is ultimately like Ethereum transaction is just one type of transaction that also has a fixed amount of gas cost,
right.
But it can also be bundled with other transactions within a smart contract.
But I'm just saying like, and again, this might be my peanut brain, but if I'm sending Ethereum from me to you, that seems like a very straightforward transaction, and doesn't really have an if then this that whatever situational tied to it.
Yeah, so
that to me, $10-20 to do that. Okay, cool.
It's a relatively low gas cost, but it does require like some fixed amount. And so, for example, smart contract operations, if Ethereum is $10 or $20, then doing like a smart contract that includes a transfer might be like $30 to $40, like a swap.
Okay, so that's what I'm asking is like, when you say something's expensive to do a contract, is it $30 or is it $300 or is it $3,000?
And deploying the contract could be thousands of dollars, for example, because you have to pay to deploy that smart contract and pay for all the storage needed to house it in a blockchain. So the initial deployment is also going to be pretty expensive.
So you have to pay for storage?
You only once up front. You don't pay anything recurring, but you do pay a fee to put the smart contract out there.
Okay.
And that's just part of the
What do you think is the most expensive, potentially hypothetical, like what's the most amount it would cost to do a smart contract? Like think it's infinitely complex.
It's okay. So theoretically, the size of a block, in the sense that a block can only do so much, like it can only do so much gas. There's actually a gas limit on the block. So essentially, the most you could do is what you could fit into a block with a single smart contract, which could be like a really fat image of a dog that you would want to put on a blockchain, even though it's a terrible place to store it. Like you could figure out a way to use up all the block space. It would just be incredibly expensive.
But what is that? What is incredibly expensive?
Millions of dollars.
That okay.
To potentially store a dog pic. And I should also reference NFTs don't, unless they're crazy, they don't store pictures on the blockchain because it's so expensive. They just store a right to a piece of art or something like that.
So potentially, if you have a contract that's the size of a full block, it could cost over $1 million just in current 2021. Who knows what in 2022 inflation numbers would be?
Yes, it could.
But it could be extremely expensive if it's the size. So the size of the contract determines the amount of the gas.
Yes, yeah, the amount of state it is going to store, the amount of code it has.
And I apologize if
no, that's a good thing to break down. That's a good question.
Okay.
So now we'll talk about DApps and adoption. So this is where I would get into use cases to really give you an idea of like, what are these being used for. So like, at least today, one of the most common things you hear about is ERC20 tokens, or just tokens, which became a real big craze back in 2017, 2018, and still like a very like important kind of primitive in the smart contract world. So like these are some like examples of people that said, hey, let me back up and say, prior to Ethereum, if you wanted to build your own like crypto token for whatever reason, you typically built that from scratch. You would probably fork Bitcoin or some other altcoin, and you would modify it a bit. You would stand up your own network. You would put up your own miners. You would do a lot of initial network setup to get it running, which is still very possible for a lot of people, but it's a lot more work than what you can do on Ethereum today, which is you can actually deploy a token on top of Ethereum. So instead of needing to create your own new network, and that also means taking the risk of your network being attacked. So if you create a small network and it doesn't grow quick enough, or it's not big enough to like handle a 51% attack, your security is not very good. But you can instead create a token on top of Ethereum, an ERC20 token that has a balance, you can transfer it, it has a limited supply, like that's codified and trustworthy. And you can, put it on Ethereum, and you can do crowd sales with that. So now, essentially with like only a few hundred lines of code, which is almost standardized at this point, you can just create a token out of practically thin air and then list it in the same way that you could a security or like anything equivalent to a payment system.
Is that why, because essentially anyone can do it, why you hear things like 99% of all altcoins are trash?
In some cases, yes. And I think definitely the low barrier to entry has led it to be used excessively a lot. But in some cases, it's also used not to be like a version of Bitcoin or Ethereum, or even something that's decently valuable. Like you can just create something for fun. Like I created an ERC20 token one year called Christmas Coin, and then I just sent versions of it to friends in their wallet. And I wasn't supposed to have any value. It was just like, I can do this because it's fun. Mm-hmm. Back when gas fees were worth it.
But that's why they say like Dogecoin. That's originally it was supposed to be fun.
Yeah,
and it still is fun, but there's a real value to it.
Yeah, but in the case of ERC20 tokens, we're actually going beyond it just being used to create like new tokens that are used in usually paying for fees on a certain service. So like Chainlink, for example, has Oracle nodes, and you pay them in their token to use them. Like that's a common model.
I think earlier you brought up Oracle nodes, and I did a comical like, oh, I don't know what that is, and I don't think we ever defined that. Is it worth defining what an Oracle node is?
I think it is. An Oracle node is just something that provides off-chain data to a smart contract. So for example, what Chainlink will typically
off-chain data.
Off-chain data. So for example, what is the price of crypto on Coinbase? Coinbase doesn't run directly on a blockchain. It's a centralized service.
Right.
So I have to like talk to a Coinbase API, and then I have to relay that information to a smart contract so other smart contracts can look at it and reference it. So for example, if I'm running a decentralized exchange and I want my pricing to be based off of Coinbase's pricing, I need an Oracle to provide that price. However, if I just say I'm just going to hook up directly to the Coinbase API using my own backend, someone could point out like, hey, if someone hacked you or you decided to cheat, you could modify the pricing in your own favor to like make arbitrage deals. So what Chainlink and a lot of other Oracle services do is they'll essentially try to figure out a way to provide it in a decentralized way. Usually they'll have multiple nodes running and providing the same data, and you get like the average of those. So if one or two of them cheat, you can tell and you can discount them and slash them, and you'll pay them in the Chainlink token. That's their tokenization model. And there are a lot of other services on Ethereum that do the same thing. We'll do a thing for you, and we've created this token to kind of fund our development, and you pay us in our token. And so it's kind of like a rewards point system, but we're selling you the gift cards before we've created the Starbucks shop, for example. And we're going to use the revenue that we get from raising all these gift cards and use that to pay for the shop. Now that gets into weird securities law, which we're not going to talk about today, in terms of like what's a security and what's not in that case.
Entertainment purposes only.
Yes. But it was a incredible funding model that led to a lot of investment and billions of dollars being raised, and a lot of projects being built as a result. Some good, some bad, depends on your opinion of them, but you did see a lot of interesting use cases for it. And now you're seeing ERC20 tokens to do other things. For example, to represent your share of an ETF or a lending pool, which is DeFi stuff we'll get into later, but it's nice because you have a way to represent your position in something beyond just like a useless token. So you can tokenize anything. That's the fun thing. In addition to that, you also have non-fungible tokens. And when I say ERC20 and 721, That just means it's an Ethereum standard that's been kind of like discussed on the forum and has, in most cases, been just widely accepted by a lot of people. And ERC 721 just says, we're going to do something very similar to ERC 20, but we're going to make it so that each asset is non-fungible, i.e. it's unique. Because with a fungible token, like for example, use a version of the US dollar, each version of that token is exactly the same. Versus with non-fungible, each one's unique. So each crypto kitty or each crypto punk or each weird graphic art that someone made is each token would be unique, even if it's part of the same collection. And that's where ERC 721 tokens have gone. Mainly, for a lot of things like collectibles and sometimes physical goods. Like at Toyota, we tokenized car parts to track them in the supply chain. And you also have people using this for loans. For example, saying, hey, if you're going to take out a loan with a specific maturity date and payment schedule, we can create that as an NFT and give you that ownership right. Or a house, for example. So there's a lot of potential for NFTs. Mm-hmm. I would say they're mostly focused right now on the silly art.
Yeah. We don't need to get into NFT conversation at this moment in time, but for me, like what NFT... what people are talking about to me are is the most ridiculous aspects of it. You know, like you just said, all the clip art and all that, and where it's like you're buying it because you think it's going to be more valuable later, or you hope it's going to be valuable. Yeah. But for me, the NFT, what the real value in it is, for a title company on a house transaction, or like you said, for the car parts with Toyota. Like, to me, that's the fascinating aspect of NFTs. The spending thousands of dollars on art that you hope that you could sell to somebody else. Like, to me, when I hear that, I hear the people that are making the money are the people creating and mining and selling, not the people buying.
Yeah. And it's definitely going to turn into, I think, a Beanie Baby craze where like a lot of people get left out in the rain. Yeah. But I think the technology is going to be incredibly transformative. And I think even within that, like a few NFTs that truly bring something special, that like are building art that actually has some compelling aspects and even some value beyond just the image, I think are going to have a lot of potential. For example, like people saying, hey, if you buy this NFT, I'm going to like put the funds towards charity, or I'm going to if you have this NFT, like for example, Gary Vee did something really cool where he put out NFTs, but they were NFTs that on a yearly basis gave you like a perk. Like you could sit down with him for lunch. You got the right to ask him to lunch every year. Or you got the right to go on a podcast with him. Or all these things that actually would have value to people that value Gary Vee's opinion and want to also kind of cash in on his influence. So influencers are doing some interesting things with this.
Yeah, so those NFTs make sense because there's you pay for a thing and you get a thing.
Yeah.
Because you brought up Gary Vee, where I would disagree with him, and again, who the hell am I to disagree with Gary Vee? Like he brings up NFTs in the sense that it's a way to prove to the world that you have money. Like it's almost like a blue check. So if I own this, I own this, I own this.
It has a certain amount of street cred to it.
Right, but street cred doesn't feed you if nobody's going to buy that street cred. So if I have a crypto kitty punk thingamajiggy that I can sell for $1 million, or it's worth $1 million, it's only worth $1 million if somebody's going to pay $1 million.
Yep. It's an art world, so it's kind of appraising things is an interesting little. It's hard to necessarily call it a clean process.
Right. Whereas like a Rolex, it's a $10,000 Rolex, which in a lot of ways it's the same thing. It's a status symbol.
Well, yeah, and what you're getting at is really what is a good store value? And I think with NFTs, it really depends more on the NFT than anything else.
I agree. I just don't think, again, who the hell am I?
But I agree with your sentiment.
Technology, the NFT stuff, I 100% agree with you. The value of the stupid stuff.
Yeah.
I get the argument that it's a hey, look at me, I own all this stuff, but
you got to be careful.
If you can't sell it, it's worthless.
Yeah. Well, and that is one nice thing about NFTs is even if you might struggle to sell it in certain markets, but you do have the ability to sell that NFT through a smart contract marketplace. Like OpenSea, for example, which is somewhat centralized, but there's non-centralized versions of it where it's just a smart contract that says you list your NFT and you sell it. And so the exchange of payment for an NFT, for example, can be built into it so that there's no counterparty. So when someone says, I want to buy your NFT, I don't have to go through an art appraiser or anything like that. I can buy and sell it directly, and the smart contract will handle the exchange of them. I'm being paid in a token or Ethereum, and then they're getting the NFT. And so that is a really I think that's why it's really transformative, because people can create marketplaces alongside their NFT very quickly, even if the marketplaces are somewhat inflated.
This is why I love Keanu Reeves, because they were asking him about NFTs the other day, and he goes, "Yeah," and then I just screenshot it, or something like that, to that effect. Yeah. So I mean, again, Keanu Reeves? Nobody's going to Keanu Reeves for his crypto or NFT information, but it was because everybody loves Keanu. It was a cute response to a ridiculous question.
Yep, that sounds like it.
Yeah.
But yeah, I would say lots of interesting stuff happening there. The place that is most interesting to me right now, and I think where a lot of interesting things are going to continue to happen, are with DAOs, which are decentralized autonomous organizations. So we have, so
I knew that.
So build, well, yeah, but build these out. Like, say you have ERC20 tokens, which are basically like kind of either money or payments or value of some kind. Mm-hmm. And you have ERC721s, which are like pieces of property. What can you do with payments and property? Well, if you can control those two things, you could build an organization that manages the money and the assets under its control. And that's what a DAO becomes. A DAO, I'll start out there, the label and the logo I'm using is actually from the DAO, which is notoriously the one that got hacked back in 2017 for millions of dollars and required a hard fork of Ethereum to reverse, which is very controversial and I won't get into. But since then, we basically learned there is like you have to write smart contracts securely or they're not going to be secure. And we've evolved a lot since then, including the fact that my company, Open Zeppelin, has a version of governance contracts for DAOs in our library that has been audited.
Wait. Apologies.
Yeah.
Smart contracts have to be secure, so they're secure. Like, because they are hackable?
They are hackable in the sense that if I write a legal contract that includes a get out clause, and I put that in front of a judge, even if it says I'm literally going to steal this person's money, if you sign that contract, you're legally obligated. So in the same way a smart contract is, you have to write it in such a way that it can't be like exploited. Same for any code.
Oh, but you were talking about being hacked, though.
Yes.
But how? So if it's on a decentralized blockchain, how is it possible that it's hacked?
So this is where like how you hack something is a bit different than a normal system. So a normal system is like usually someone builds a big moat around it. Like they have a big firewall and they try to keep their code safe so no one can come in and inject things into the code. In the case of Ethereum, there is no moat because the thing is put on a blockchain and it's open for everyone to see. But if someone being able to scrutinize that can see that someone left a hole, it's like you have a house and anyone can look inside your house, but someone looks really closely and they find out you have like a little doggy door that you never lock, they'll get in. In the case of a smart contract, if you write the code with like a bug, in the case of the DAO, it was a reentrancy bug. So what happened was someone called a function that was supposed to withdraw funds from their account to the DAO, but there was a point at which they were being sent those funds. Or actually, it was a withdrawal function. So basically what it did is it said, hey, I'm going to check your balance. Your balance is this. I'm going to send you the money. And then after that, it removes that balance from your account. So basically, it does this subtraction after it sent you the money. The problem was someone was able to figure out a way where once they're sent the money, they get temporary control of like the call stack. But basically, that means they're currently in control of the execution. And they figured out a way to re-enter the smart contract and hit the withdrawal again. So it kept looping. It went, check your balance is good, send you the money, and then they recalled it, check your balance has not changed because it never got to the update state after sending. So it just kept looping through and sending them the money. So it just kept duplicating their balance way beyond what they actually had. And that's how they were able to get millions of dollars. So like these little like logic bugs that are left inside of a smart contract are still dangerous.
But I guess the question I would have though is, even if there was a hole, exploiting that hole would require to change something in the data, right?
No. Well, you're changing it in a way that the smart contract technically allows. So it's like it is essentially, it's like you find a legal loophole where like if you go in front of a judge. And like the intent of the contract was not to let you get away with like millions of dollars, but the contract is written in such a way that you're technically allowed to. Legally speaking, it's hard for you to actually be said that was wrong because the other person agreed to it. And by virtue of working with the smart contract, you're agreeing to allow it to execute things as it was programmed. That's why programming a smart contract securely, which is a big part of what we do at Open Zeppelin, is so important. In terms of we like provide tools for doing it more securely, and we audit other companies that build smart contracts to make sure they do it properly.
So, and again, I hate to be an hour into this.
No,
and
this is an important part to dig into, because this is where you trust a smart contract.
The whole point and again, the whole point to me, the whole point of smart contracts is, it's secure, it's non-fungible, it's the blockchain. But if I'm hearing that, by the way, it can still be hacked, well, then what's the point?
I would say the difference is that you still have these three properties. It's still immutable, verifiable.
I'm not attacking you.
Oh, no, I know. But I'm breaking that down in terms of you're protected against large third parties, but you're not protected against people that essentially can figure out a workaround or a cheat code. And so really what we need is a really security-focused environment.
Right.
Where before consumers actually interact with this, there's like a template, like those templates we were talking about earlier that have already been really ironed out and cleaned up and audited to the extent where they're trustworthy. And that's what you actually end up using and engaging with. So this isn't the kind of world where anyone just writes a smart contract and puts it out there and then millions of dollars move through it, although that has kind of been the world up until recently. What we're moving towards is a world where smart contracts are still going to be accessible to anyone, but to actually be trusted by people requires you to either have used existing tools that are secure or done a lot to show you're secure. Because the risk you run on the smart contract is not the platform or a third party. The risk you run is the code. The code is still a risk. And it's a risk that is knowable in the sense that if you have the know-how, like an auditor or anyone who knows the technology can look at it and determine does this have a bug or not, although there's always room for human error, you eventually over time can get that verified. And it's public and it's transparent. So, the alternative is Bank of America, where they're like, we're going to, even if there are bugs, we're going to try to figure out how to resolve them and try to make you whole at the end of the day because they don't want to get sued. But they do have decision-making power over you. Whereas with the smart contract, no one does. You just have to make sure that the code is secure. You have to read the fine print very finely, or at least very carefully.
So that makes sense. But at the same time, I think for me at this moment, it's going to take a minute for me to understand why somebody would use this technology if it's the same hassle of everything else in the world. Because you still have you're still the risk of being hacked.
So I think, and the whole point of blockchains aren't to eliminate the risk of being hacked. That was never the point. The point was to make it so that it's decentralized and people are openly able to engage in that system, even if there's still risks. I would say the value, and this is where I think Ethereum, for example, is not consumer friendly yet. It still needs to get there. But most individuals aren't going to be interacting with smart contracts. They're going to interact with applications that use smart contracts. And it's going to be up to those developers and product creators to figure that out, not the consumer. They're going to figure it out for the consumer and present something that is trustworthy and accessible, kind of like Coinbase already does. But I do think that what you're going to see is because of the way open source works. For example, Bitcoin. Bitcoin's a great example of it's an open source piece of code that over the years is just so trustworthy that you can fork it and you can know that it runs pretty much exactly as designed. It's been proven out over 10 years. Smart contracts are in the same way. Like the ERC20 contract is fairly proven out as being secure after going through a lot of trial and error. So over time, you're going to see these smart contract templates that become, and they're open source, so anyone can use them, become trustworthy and become something that people can depend on, and then very easily extend and use in certain circumstances. So it's just like using a mobile phone was kind of risky in the sense that some of them didn't have very good security, some of them could be hacked, but I think the difference here is that unlike with phones and a lot of software out there, only that company or only that hardware manufacturer is able to improve their security through their own internal learning process. In the blockchain and smart contract world, it's an open system. So you can learn from other people's mistakes. You don't have to make those same mistakes yourself, at least for developers. This is where consumers, I think, don't need to poke their head in too much. All they need is to be able to find trustworthy people to use these contracts through.
Even in this setting, earlier when you were talking about the code, I was like, well, I don't need to know that. But I think a lot of people had my same revelation I had, which is wait, it still can be hacked. It can still be that. Because I think, and again, this is only episode 5, but it's it's safe, it's secure. Oh, it's not. Oh.
It's not a blank
check.
So
therefore, you need to hire a Mike Llewellyn to do you smart. But I guess, I mean, you said that, I guess your industry is smart contract security, right?
It's full industry, and I think it's
Yeah.
one that we hope to be less necessary over time. And I think what we're going to see is the attack surface is going to move away from the simple stuff to the more complex stuff. So like right now, no one really hacks an ERC20 token like they used to because it's so well understood how to avoid that. In the same way that like no one gets hacked through their email client because you figured out how to protect against like basic stuff with a firewall. So over time, like think in blockchain, the security issues are going to be solved, and the biggest thing is just figuring out what they are. And I think with blockchains, the difference is that you are able to be responsible for your smart contract security. You always have that option, but you also have the ability to rely on others in cases where you choose it. So there's still an open market, and there's still going to be dependency on, like, for the average person, they're going to have to depend on other people that know more than them in terms of like how you interact with the smart contract through like an existing app, you know, like a dashboard that gets rid of all the complicated stuff and it just gives you a simple UI. And so there's ultimately going to be like people that have to navigate that for the rest of the consumer market. But yeah, I guess coming all around to it, what I am very excited about with like the way DAOs and others operate is it's completely transparent, it's open, and it has a lot of potential for like for example, for these things to be composable. Like you can take an ERC20 token and a 721 token and a DAO that were made by 3 different people, and they can all talk to each other and work together.
Now, is that because that Turing-complete aspect?
Kind of. It's mainly because they're all existing on the same network that is got a shared security model. So like, for example, if I wanted to do an integration between my PayPal account and some like third-party marketplace that were both like normal centralized apps, I have to do it like PayPal or that company have to directly integrate it. They have to do the work to plug it in, and maybe they have to sign like a license contract. Maybe they have to do an actual partnership. So there's a lot of business steps involved in doing that. Whereas in like the smart contract world, you can just hook things up. You don't need permission. You can plug something in immediately and build a product on top of someone else's product and build this really composable layer. And that's, I think, what's really powerful about Ethereum is you have a financial ecosystem that can be interconnected far faster than it is in the current world, where like, you know, doing a merger and acquisition or doing partnerships or sharing, just, you know, allowing a competitor to use potentially some of your tool sets are like very frowned upon, or at least it doesn't happen a lot. Or if it does happen, it takes forever. Whereas with this, it can happen immediately. It's open source and no one has to ask for permission. And so you build some really interesting products and services that way that I think are going to accelerate over time in terms of their development and like the new things they can do that just couldn't be done differently. Like DAOs, for example, mean that now you can raise money through a token, and you can give the people that raise that money the ability to vote on what decisions you make with the money that sits in the DAO, and then it executes fairly, which is like, that's the same power that shareholders have in a publicly traded company. But getting to the point where you have a publicly traded company is a far longer, more expensive process than deploying a few smart contracts. Now, that also comes with regulatory uncertainty in terms of like, what can a DAO do that a shareholder entity can't, and how it gets legally registered, et cetera. But just the ability to do it, I think, is going to cause some really interesting business models to come out. Like, for example, like I can vote. For example, a really fun is constitutional DAO. Have you heard of that?
I haven't heard of any DAO.
So, yeah, the constitutional DAO.
Have you heard of constitutional DAO? Okay.
Okay, so the constitutional DAO was a DAO that was made for one purpose only, which was to buy a copy of the U.S. Constitution. It was literally people saying, I'm going to put money into this DAO, and it's going to be like run, and all the token holders will vote on how the money is spent. And the way the money needs to be spent is we're going to try to like bid on this copy of the Constitution. Now, it didn't end up working because they got outbid by someone else beyond what the DAO could raise. But this is like a good example of how someone, just like a random group of people, can say, I want to organize around something that we want to accomplish. And they don't really need any like direct legal structure or entity. They can just say, put out a DAO. Anyone who puts in money gets a voting share equal to the amount of money they put in. And we just go out there and we do it.
So it's almost like a GoFundMe, but when you fund it, you have like a voting right of how much you put in.
Yeah.
To do whatever you want with it.
And that could also
and then also there's no overarching organization company that's taking percentages or anything from it.
Exactly. It's directly the DAO, controlled by token holders, and they could do profit sharing, they can do payments. For example, my company just was selected by the Compound DAO, which is a lending protocol, to do their security, and they actually had to vote on that. The token holders voted on who was going to be their security partner, us or a few other competitors.
So when I don't know how familiar you are with like real estate, but like for apartment investing, they do what they call a syndication, where they'll like, so I have a contract in an apartment complex. I'm going to retain 20% ownership of the thing as a management, and then I'm going to go raise capital to purchase this thing, and the people that are funding it, they're going to get 80% of the deal. I retain 20%, and because I structure the deal, I retain that 20, even though I'm not putting in my own cash. Like a DAO, would that benefit in that situation, or because I don't know what I'm trying to ask, but I'm just trying to think in terms of the capital raise, and it's like because it's on this blockchain, it's like, hey, you own this, you own that.
Yeah, and like
I don't know what I'm asking.
I think I get what you're getting at. Like, where's that benefit? And I think like putting aside some of the scalability and like legal uncertainty that exists in the world, which I think will be resolved, I think the real advantage there is like normally you need like a strong accounting system. Like you have a CPA, you have financial advisors that like work in that sort of organization to make it possible.
Left and right.
Yeah, contracts left and right. Like real estate is notoriously difficult to manage. In kind of an ideal world here, you could have a DAO that manages most of that. You might still have a management company that does the day-to-day work, but it works on behalf of the DAO, and maybe they take a smaller cut as a result because it's more competitive. And the DAO has direct control of the assets as an NFT, as like a title of real estate, and the payments coming from the renters to the DAO are immediately dispersed to token holders or dispersed in whatever way they decide on. And so you actually have this direct mechanism where they're not relying as much on the. Basically, what happens with most real estate companies is you rely on the company to act honestly, and if they don't, you try to take them to court. Whereas in this case, you would have far more guarantee built into the system because you can see how the money's managed, and the decisions for how that money is allocated is directly a result of token holder decisions or DAO decisions. So that's where you tie things together that are normally entirely separate or manual processes that have become, I guess, smart contracts in the sense that they're automated on a blockchain, and so. You don't have to worry about whether the company will do the right thing. It's kind of built into it. And that's where it comes back to you've taken the risk from like a company or the leadership of that company or specific individuals, and you put it onto the smart contract, which is why you still need to secure the code. The risk still exists, but I think what we're trying to get at in this world that we're working in is over time, code on a blockchain is more trustworthy, even if we have to take the time to do it right. Because even if someone can hack it, it's not going to be malicious. It's just going to be doing what it's told.
So in comparison to this episode versus episode 4, I think episode 4 broke my brain and melted it more, whereas this one, it seems like there's a lot more philosophical / discussions, and maybe that's just because that's the direction I took the conversation at times.
I think the industry is also trying to work through like what are reasonable use cases for smart contracts and what are the trade-offs, and that's ultimately why I always stress like, do you really need these blockchain properties? Because you're still getting a trade-off. Like you're trading off the security reliance on a centralized party, but you're also giving up some of the convenience and scalability of that to go to decentralized systems. Do you need decentralization? And I think in some cases over time, we're going to see different layers or degrees of decentralization. Like, do you really need to run on mainnet Ethereum with a DAO, or would it be okay if you ran with like a few multi-sig signers and ran that on a side chain or a rollup that was way cheaper? So there's trade-offs that exist, I think, and it depends a lot on your use case and what you're doing with it, on whether you need to be like fully decentralized or you're just looking for a bit of it. You want to be more decentralized than the current competitor or thing that exists to do the real estate or whatever, but maybe you don't have to go all the way. And that's, I think, where there's still a lot of open discussion on what makes sense, because these are all still like new business models we're playing with.
Mm-hmm.
So from there, adoption challenges, which is what we've already been talking about, which is despite early success, smart contracts have a long path before we see wide-scale adoption, as in like the average person interacts with an Ethereum smart contract in some way. Right now, most people don't. It's mostly either people playing with DeFi or investments in crypto, with only like a few specific use cases from governments, like actually utilizing the blockchain in a direct way. Usually in like small POCs or like proof of concepts. So we mentioned security vulnerabilities. That's still an area that my company and a lot of others are focusing on trying to improve. But it's going to take time, just like the internet took a while to resolve all these awful security bugs that come with it, and sometimes still do. It's just going to take time and energy and education to resolve that. Legal recognition and compliance, which is what we work on a lot in Texas. Recognizing DAOs as legal entities, recognizing transfers and commercial contracts on smart contracts as legally binding is a big part of that. So like if an institution wants to use a smart contract, they in some cases might still want some legal recognition of it, even if they're trusting the blockchain to execute it more than a court. That's where you have to provide a lot more definition.
So
and guidelines.
you just mentioned like legal representation. Now, does a DAO, do they have to, when it's formed, do they go get registered as an LLC?
That depends on the DAO. Like by design, it doesn't need to. It can do what it wants. But the question is, does it need legal recognition to do what it wants to do in specific jurisdictions? Because the blockchain doesn't care about jurisdictions. It just does things.
Right.
But in practice, a DAO might need to employ people in a specific state, or it needs to do other activities that are only done by a business entity if you're trying to engage in the real world. And I think that's where a lot of guidance does need to exist. Like Wyoming's already working on some DAO structures. We've got it on our plate, I'm sure, with the TPC and what we might be doing in the next legislative session. So that's a really important part where, no one wants to work with a DAO if they can't trust it actually has some sort of a legal entity. Because even if DAOs don't care about anything but the blockchain, other people need a legal framework in which to engage with a DAO. Mm-hmm. And it's a challenge for us too. We basically were more relying on code than contract in our security arrangement with them. User experience and key management is another one, which is basically having a good interface to work with, understanding what you're doing, and having keys in a place that's safe. We've talked about key management before, but I think that is always going to be an ongoing thing, because if people don't have key management that is both trustworthy and relatively under their control, it kind of defeats the purpose. Or at the very least, they understand how the keys work, and even if a third party holds them, there's some protections for them. Mm-hmm. Transaction scalability and throughput. So Ethereum is fairly limited in what it can do today. There's rollups and side chains and new Ethereum 2.0 upgrades coming that are going to improve that, but it's going to be it's going to take several years before we see full-scale adoption throughput available. And even other blockchains that are doing what Ethereum is doing, but they're trying to make changes that add to the throughput with trade-offs, even they will hit limitations at some point. It's just it's a matter of time. So over time, transaction scalability and throughput is going to be a big challenge.
And what do you mean by throughput?
Just the amount that can go through per second. Okay. Bigger throughput means more transactions per second, essentially. And scalability, in general, just means more transactions, but also it can support a bigger network, and it can scale in a lot of other ways too. So ultimately, smart contracts require a lot of existing processes to be potentially modified and changed, but it requires time and effort to adopt and scale it. So we have this lovely hype chart, which was from 2019, but you can see that at least back then, and maybe it's further down the line, smart contracts are right at the top. Everyone's got these crazy expectations for them, and we have yet to go through what does this actually mean in practice. I think we're probably going down a little bit here. I'm not entirely sure where we are in 2021 now, but I would say we're definitely at a point where we've had a lot of smart contract hacks here and there. We've had the same realization you went through today of this isn't just a silver bullet to being hacked, mm-hmm. but it does address some issues, and people have to go through this inflated expectations and trophy disillusionment before they finally get up to this slope of enlightenment, i.e. we really know where it applies and it has long-term success. And I think we're still working through that. So they're not the best choice for every use case. They can't replace legally binding paper contracts in the sense that if you need legal recognition, you're probably still going to have a paper contract. You could create a smart contract that reflects a paper contract exactly. So you let the smart contract handle the execution, but you might still need a paper contract just for the simple sake most businesses wouldn't feel comfortable otherwise.
Now, do you see, but when do you see smart contracts getting into the legal world and getting into legislation? And I know that comes with politicians being educated in this field, but is that a 1 to 3 years, a 3 to 5 years, a 5 to 10 years, 20 years down the road?
I mean, in a sense, we already have. For example, the UCC bill that we passed here in Texas, the Bitcoin bill, does address smart contracts, not directly, but it says basically if you have for example, a multi-sig arrangement, to resolve a lending issue. Like the result of that transaction effectively decides the issue of who has control. And that normally had to be a UCC filing. So we have kind of, which could be a smart contract. It could be both a Bitcoin transaction of private keys, or it could be a smart contract that resolves it. So we've kind of controlled it there, but I think overall, in terms of like truly integrating smart contracts into the legal system, we are probably 5 to 10 years away. Because the court system is going to have to change so much or accommodate so much to really bring it in. But I do think we're going to see it in like just small pieces here and there. For example, smart contracts are going to come into court cases to resolve a court case to say, hey, the legal document we created was based on the smart contract. The smart contract says this. Therefore, in court, we should follow the same conclusion. So you might see a court system use smart contracts to ratify or resolve a decision, for example, because it's all verifiable and immutable, and you can kind of reference the fact that both parties agreed to it through their private keys, as long as there's an understanding the smart contract did what it was supposed to. There's been some court cases resolved through that with copyright disputes, because some people like stored the hash of some copyrighted work and was able to like detect it using a smart contract. So there's a lot of interesting like edge cases that we'll see bleed into, I think, the legal sphere. They cannot replace compute-intensive workloads. So like you're doing something really computationally intensive, you're storing a lot of files, for example, like databases and large volume data storage. Blockchains are going to replace this. Like, you know, the vast majority of data will still exist in like a normal database, but a blockchain could be used to verify that data in a really short format. This is where hashing comes into play. Like you being able to say, like for example, taking an image, like a cat picture that we want to create as an NFT. I don't put the image on the blockchain, but I could hash the image and put the hash in the blockchain so I can reference it and say this owns that, and I can prove it because the hash matches. So you can do interesting things like that, but there's a lot of things you don't want to do in a smart contract.
And that's typically what an NFT is, right?
Yeah, exactly.
Okay.
So, and I think that's one of the biggest things you have to resolve with most people is like the image isn't on the blockchain because that would be expensive and dumb. It's just a token that represents the image itself.
And just to go back on shitting on NFTs, this is because the whole point of a non-fungible token for the image is like, hey, this is unique, but you change one pixel, that's also unique.
Yeah.
So you could literally have almost it's not infinite, but you have a seemingly infinite variations of one image, like because each pixel can be changed.
Yep, you could. And a lot of the NFTs do that in the sense of like, you know, they have a different hat, they have a different mustache, they have like these different attributes. It's like an avatar that you can swap out accessories with.
But again, to me, it's the emperor's new shoes in the sense that it's like the value is there based off of somebody else giving it value.
Yep.
Which I understand is everything, but you can't live in an NFT. You can live in a big ass house though.
Yep. Until they become one and the same, but that'll be a while.
Yeah. Again, that type of NFT I'm on board with. I get it. Anyway.
Yeah, maybe they'll when you buy your house, they'll throw in like a CryptoPunk NFT just for fun. Yeah, they'll bundle it.
Oh lordy.
And then the last point, of course, is anything that can be reasonably entrusted to a third party. So I say this because most of the time when you hear a crypto blockchain person talk, they're like, third parties are just awful, like screw them. But in reality, there's always going to be a need for a third party, and if you can trust a third party, or if they can act honestly, in some cases they might be better than using a smart contract. Like if you can figure out an arrangement for like whatever use case or business arrangement you're talking about, where a third party can make sense and doesn't have a big risk, it might make sense to just go with that route. I mean, for example, for some payment processing, it might not make sense to use crypto if you're not worried about your merchant screwing you over. If you feel like you can reasonably trust them, continue to use the merchant. Like if it ain't broke, you don't necessarily need to fix it with a blockchain. That being said, I think long term there might be some really interesting ways we disrupt those markets and third parties still exist, but they might become less necessary. But that's a world that I think is going to take a while to evolve. And for today, like third parties are always going to exist and are still a main way we do business today. And so, yeah, I would say don't try to decentralize everything necessarily, even if it's fun to think about. Focus on what like really matters today, which are usually specific use cases where like third parties are very difficult to deal with, or they just like you can't even get a third party. For example, banking in Africa, you can't even get a bank, so you need something.
It goes back to your Christmas coin.
Yeah.
don't necessarily do everything because you can, do it because there's a reason, there's a value, there's
and the case of the Christmas coin,
function.
that was entirely for fun. I could have sent people holiday cards, and it would have achieved
But I'm
the
just
same
saying
thing.
in terms of the usability of all this other stuff.
Exactly. Yeah, and it's definitely, it's trickier, it's more complex, but there's still some fun things you can do with it. It's just take it with a grain of salt and check out the chart. So that's pretty much it in the sense of smart contracts. They have a lot of potential. There's also a lot of other platforms out there. Hedera Hashgraph is one of our council members. They also have Rootstock, which is trying to run Ethereum on a Bitcoin. They're trying to do an interesting version of that. EOS, which is kind of old news. I would say Solana is kind of the new EOS, but like trying to make smart contracts faster while still being somewhat decentralized. And then Hyperledger, which is like trying to make private permissioned versions of blockchains that do smart contracts. These are all now, like with Ethereum, it's kind of like built out this massive explosion of other people trying to do the same thing of being the smart contract platform or a way to build smart contracts.
So I guess we can circle back to my question from earlier. Where do you see all this going? Like, do you have predictions of? Because if the answer is, well, it can do everything, well, then the answer is nothing. So what are specific everythings where do you personally see this going?
I think I see this moving in a direction where a lot of like new financial applications are going to be built using blockchains, and I think they're going to eventually get to the point where they compete with modern finance in a way that it really isn't prepared to deal with. And that's where like a DeFi conversation would go deeper, because I think that's definitely the most valid use of smart contracts we've seen. And in a way, it's kind of self-perpetuating, because it's saying we built a market, we built tokens, and now we built a market for tokens, and we're building from this. That's kind of abstract. But like, for example, being able to do specific lending arrangements that are just not possible in the real world because of the fact that like it would be so expensive to get that legally arranged with just third parties. But with a smart contract, you can make assumptions for how it's going to behave and make like really small deposits or really small borrows or loan money to someone without even knowing who they are, where like a lending provider can't do that in the real world. They have to have some guarantee of getting it paid back. Whereas with a smart contract, you can build in guarantees. That's kind of just one example, but I think growing from there, we're going to see more and more use cases that touch these new, like I think honestly some of the best use cases for smart contracts are things we don't do today because they're just not possible and we've never even thought it would be possible.
So in the way that the internet revolutionized the music industry, do you think blockchains will like the financial industry?
Absolutely. They already are, I think. Okay. And I think that it's going to accelerate over time because it's just going to introduce these models of handling money in a way that just moves far faster than the finance industry. And I think at some point, not today, but at some point might be more efficient.
Now, I feel like a lot of my questions today might have been off topic. Is there anything that I miss as far as being an advocate? Like, what do you think when you were taught this in school? Like, what out of this presentation confused people? Like, was there anything, the hangups? What are their most frequently asked questions?
You asked a lot of them in terms of like, really questioning where's the security, like what's the risk with smart contracts if it's so to speak hackable still, and like trying to understand that. And actually I'll wrap this up and say like these are some of the interesting use cases we've seen. So JP Morgan, Starbucks, Santander, and then like other video games like Gods Unchained are now using Ethereum or blockchain-like instruments to kind of like do some interesting use cases.
So blockchain-based coffee?
Yeah, and this is actually, I worked on a similar project before, a startup called Ceres, which is still here in Dallas, where we tracked coffee from the farm all the way to the grocer, and the whole idea being like you could prove that it was locally sourced, it came from this place, and the coffee was using an IoT device under proper conditions throughout the trip. So it didn't get too hot, it didn't get too humid, it was just right. And that was tricky in the sense that you still had to rely on IoT devices. So it's not smart contracts aren't the only thing that are needed to make that happen. But I think what it ultimately ties back to is like now you could trade that coffee on a marketplace that's verifiable versus trusting a third party to verify it, which in many marketplaces are how you have to do things. You can only specific parties engage in these large commodity exchanges or marketplaces because they have a trusted reputation. And with a blockchain system, if you build it right, you might not need that, or at the very least, it's less necessary to be trusted.
Paul, questions? Did you get all of this?
Yep.
Kevin? You're good? Okay.
All right.
Well, I guess if you have any questions out there, feel free to drop them in the comment section. We can get, I'm sure not me, I'll get Michael to answer them. And if you would if you have questions that, like say in these 1 through 5, these episodes we've done, if there's ever a point where you're like, hey, can you go more in depth at that? I'm sure we could throw in some.
Oh yeah, we could do like a Q&A at some point.
Yeah, or maybe not a Q&A, but just like, oh, this is episode 3.1 or something. Like maybe we have to like go back, follow up, a summary, or go back into it. If you want information about the Texas Blockchain Council, go to texasblockchaincouncil.org. Follow us all over the internet. Michael, where can they follow you / what can you do for the millions of viewers?
You can follow me on Twitter at @LlewelynMichael, and you can also see me on LinkedIn and all the other places that I hang around. And come to the Blockchain Council meetups. That's another place.
Yeah. As far as business, like, are you looking to do business with people, or do you have a thing you could sell, a product you could do for people? Like
mainly Open
plug
Zeppelin.
away.
Yeah, I mean, Open Zeppelin's the main thing. That's where I do a lot of smart contract auditing, mainly as a project manager. And so we're always like looking for new clients and opportunities. So either are you looking to use security tools? We have a lot of those through our contracts library and our Defender product. Or if you're looking to get an audit, definitely let us know. We're usually booked up for a few months, but we're always interested to talk to new people and learn about new things.
Yeah, and I'm Ryan Harper with Harper Belmont Media. We're a media company, and we do productions like this. We do events. We do media stuff. But ultimately, I'm just here to learn more about crypto. So definitely check out Texas Blockchain Council. Ask your questions in the comment section, and we'll see you next time.
All right. See you later.